Have you ever heard of quantum computers? These machines use the mystical phenomena of quantum mechanics to deliver huge leaps forward in processing power. Quantum computers promise exciting advances in various fields such as materials science and pharmaceuticals research. Companies are already experimenting with them to develop things like more powerful batteries for electric cars and novel drugs. So, what are quantum computers? Traditional computers work with bits which are binary, either a 0 or 1. Quantum computers, on the other hand, use quantum bits or qubits which can be in a state of 0 and 1 simultaneously. This allows quantum computers to perform certain tasks much faster than traditional computers. But how do qubits work? Qubits rely on a phenomenon called superposition, which allows them to exist in multiple states simultaneously. This is what gives quantum computers their immense processing power. Qubits can also be entangled, which means that the state of one qubit can be instantly affected by the state of another, even if they are far apart. Now, you may be wondering, how do we build a quantum computer? Building a quantum computer is an incredibly challenging task. Quantum computers require a controlled environment with minimal external interference. They need to be kept at incredibly low temperatures, often just above absolute zero, and in a vacuum to reduce interference from the environment. One of the ways we can build a quantum computer is by using superconducting circuits. At ultra-low temperatures, certain materials become non-resistant. Electrons move through these materials without experiencing any kind of resistance. This is what makes them superconductors. The circuits in quantum computers use tiny loops of superconducting material to create qubits. When electrons travel through superconductors, they group together to form something called Cooper pairs. These pairs can move across barriers or insulators, which is called quantum tunneling. It's kind of like a secret way to get through a locked door without needing a key. Another approach is using ion traps, where ions are suspended in a vacuum and manipulated using lasers to create qubits. But why is the development of quantum computers so important? Well, quantum computers can perform certain tasks much faster than traditional computers. One such task is factoring large numbers. This has important implications for cryptography, as it is currently difficult for traditional computers to factor large numbers, which is why much of our online security relies on encryption algorithms based on this fact. However, quantum computers could potentially break these encryption methods, which is why the development of quantum-resistant encryption is a growing area of research. Quantum computers can also be used for simulating complex systems such as chemical reactions, which could revolutionize the field of drug discovery. Quantum computers could also help us develop better materials by simulating the behavior of molecules in different conditions. Quantum computers are really good at solving optimization problems quickly by testing out lots of potential solutions at once. For example, Airbus is using quantum computers to calculate the most fuel-efficient ways for planes to go up and down. Volkswagen has also created a service that uses quantum computers to figure out the best routes for buses and taxis to avoid traffic. Some scientists even believe that quantum computers could speed up artificial intelligence. However, quantum computers may not reach their full potential for a few years yet. The universities and companies working on them are struggling to find enough skilled researchers, and some important parts are hard to come by. However, if these remarkable machines can live up to their potential, they could change whole industries and supercharge innovation around the world. So that was all on quantum computers. We hope you liked the video. Thanks for watching, and don't forget to subscribe for more awesome content in the future.